coming to this problem, we see that two bodies have been tossed. Let's take this as the origin point. So particle 1 has been tossed vertically and particle 2 has been tossed at an angle of 60 degrees. So if I consider this, let me get a straight line here. So I consider this as the horizontal, then the angle between the direction of light or the angle in which it was tossed was 60 degrees, whereas this particular body has been tossed in the vertical direction. So this is the particle 2. So we have been asked to find the distance between these two bodies after a time 1.7 seconds. So first I'll consider this as body 1, this is body 2. So this would be the x-axis and this would be the y-axis. An approach for this would be for solving such types of problems would be using the vector components of each individual bodies. So for the first body, there is no x component, so it would be 0 because the body is moving completely in the vertical direction, whereas the y component of displacement for this body would be displacement d is equal to ut minus half g t square. So we are taking after a time t what would be the y component of displacement for this body. Okay. Similarly, but for the second body, because it's thrown at an angle, it would have both x component and y component of directions in terms of its displacement. So if I consider the x component, I would get in the x component it's a parallel, so there's nothing that's acting on the body. So the displacement in x component would be equal to u cos theta, where theta is the angle at which it was thrown, into time t. Whereas it would not be affected by acceleration due to gravity because that acts only in the y direction. So coming to the y component of motion would be dy would be equal to u sine theta into t minus half g t square. So getting some space here. So the displacement, so if I tend to represent this as x component of the vector and y component of vector of the displacement, the displacement of body 1 would be equal to 0 into I cap, where I is the directional cosine in the x direction, plus ut minus half g t square into j cap. Similarly, if I were to represent the displacement of body 2, it would be u cosine of theta into t into I cap plus u sine of theta into t minus half gt square into j cap. So I write d1 is equal to ut into j cap minus half gt square into j cap, and displacement of body d2, the distance traveled by body d2, is equal to u into cosine of theta. I just move t here so that it looks like ut into cosine of theta into I cap plus ut into sine of theta into j cap plus, it's a minus half g t square into j cap. So the difference of the distances between them would be d1 difference d2 would be equal to, so if you see, I have some common terms which I can eliminate easily. So I will eliminate this particular term, half gt square into j cap and half gt square into j cap, this one and this one completely, and I'll be left with, so this is minus ut into cosine of theta into I cap minus, sorry, plus this one into I cap is done. Now we will go to j cap, ut into j cap plus ut into sine theta into j cap. I'm sorry, this should be minus. Okay, so just putting it in terms of individual vector components, ut cos theta minus ut cos theta into I cap plus ut minus ut sin theta into, sorry, j cap. So this is how we get the vector for which the distance is to be calculated. Now all we need to do is just the magnitude of this, which would be difference of d1 minus d2, that would be equal to, magnitude is square root of cos theta whole square plus ut minus ut sin theta whole square. So this would give u square t square cosine square theta plus u square t square, this particular part, plus u square t square sine square theta minus, I have to multiply this 2 into 2, just a plus b whole square, 2 into u square t square sine theta, of course the square root included. So this would be equal to, I have to get all the u square t square into a single side, and adding up these two u square t squares, I would get u square t square into cosine square theta, and getting this one here, plus sine square theta, so plus this one 1 plus this term 1 minus 2 into sine theta. Of course the square root is still on, so that would be u square t square into sine square theta to sine square theta is equal to 1 I'm sorry, I think I put an additional 1 here which belongs to here, sorry, I'm sorry. So that would be 1 plus 1, which should 1 plus 1 minus 2 sine theta, of course with the square root still on. So that would be equal to u square t square into 2 minus 2 sine theta, square root is still on. So that would be equal to ut, if I can get this ut out, into 2 into 1 minus sine theta. So substituting all the values here, this value, if you substitute the value of u equal to 25 into t equal to 1.7 and square root of 2 into 1 minus sine 60. You just solve this arithmetically, you will get a value of approximately 21.67.